How well did your design meet the specifications of the performance test?
So the goal for our design was to have this arm approach the burger flip as if it's here, and then the arm would go down and then lift up the hot plate. So the hot plate's at like a 45-degree angle, then drive forwards until the hot plate falls down, and then the robot would back up, lower the arm, or raise the arm, move forwards, and then tilt forwards again, and then push the hot plate back. So we basically just measured the arm so it'd be at the right distances for that. And then we also made sure our arm was the right length so it could easily just like hit the ice cream levers when it was close enough. And to hit the ice cream levers, it just picked up, and then once it was close, it lowered.
Did your design perform as you expected it to?
So the arm for moving the burger flip worked as we expected to, but we were having troubles getting up the ramp because of the rubber bands. They seemed to be like really dusty, so we had to clean them off in order to get up the ramp because it was affecting our distances with everything else.
What are the strengths of the design, and what elements should remain the same going into the next performance test?
The aluminum arm was really sturdy, and because it was long, it was able to flip the burger really well. When we were lined up properly, it was also really consistent. We're gonna keep the design mostly the same for the next performance test. We're just gonna change how the wheels work.
How can the design reasonably be improved for the next time your robot needs to perform these tasks?
The main thing we're going to change is with these wheels that are powered by the motors. So we were having some issues with like the rubber bands getting dirty, and that was causing the robot to slip as it was going up the ramp. So we might end up changing out the rubber bands, which will just give it more friction so it's more easily able to go up the ramp without slipping. And also we're considering redistributing the weight, because right now our robot's front heavy, and if we have it more balanced, we could have the robot drive up the ramp backwards, which would be a lot more effective with getting up smoothly.
What problems did your robot experience, and what were the causes of these problems?
We had a lot of issues with RPS because the values for RPS are different at every course. So sometimes the robot would be lined up really nicely with the burger flip, and other times it wasn't. So a way to solve this, we're thinking about either just hard coding like values for each of the courses, or we might implement something in our function. So before it, like after it has us say which RPS course we're on, we could manually put the robot exactly where we want it to be, and then record that RPS value and put it into our code. By having that, we would know that the RPS value is exactly where we want it to be.
It needs to go forward, and he looks so scared. Before he got out of it, like, he looked so like, dude, I don't know if he at the top here,
Who's still here? Only Tony? Okay.
Dude, that's a really way to really back.
Yeah.